Hello, this is Tom Repass of Canyon Rim Honeybees in western South Dakota. This next presentation in our series on raising queen bees and breeding honeybees, designing your breeding program, gets into the details of how to design a breeding program to help you produce the types of queens which produce the offspring with the characteristics that you desire. Now, many queen bee producers simply produce queens without really selectively breeding. Sure, they may eyeball a colony and pick a queen that from a colony that produced the most honey last year or something like that, but really without going into any specifics on selective breeding. So this presentation really gets into honeybee breeding and how to determine which queens to breed, how to select for mite tolerance, and what type of breeding program you should use, as well as a tool very useful in livestock breeding that hasn't been utilized that much in honeybee breeding called selection index. Well, which characteristics should you select from to breed? Well, some characteristics which beekeepers select for include the following, and it certainly isn't limited to only that. Honey production. Obviously, we want our bees to produce honey. Gentleness, hygienic behavior and Varroa resistance, the ability to overwinter, and so on. You need to be careful because if you aggressively select for only one or two traits, you might have unintended consequences in other traits. For example, strains of bees that were selected aggressively for Varroa resistance might not be as productive or might not be as gentle or have other undesirable characteristics. You need to select from a group or handful of characteristics to try to have bees that have all of the characteristics that you want. Assessing your queens. Indeed, you should assess your queens every time you look at a hive. Now that doesn't mean obviously that you need to actually see the queen every time. But even if you're not breeding queens, you should always assess whether or not the hive is queenless and needs a new queen, if the queen is failing and she needs to be replaced, if there's emergency replacement cells versus supersedure or swarming behavior. And then finally, for this presentation, determine which queens you might want to keep for production and which queens you might want to replace versus those that you might want to keep as your future breeding stock. Now this list, these next few slides, is certainly not meant to be all of the characteristics that you might assess or you might want, but some things you might pay attention to. Gentleness. Obviously, if you've got that one colony that, half the colony comes out at you where all the other colonies are ignoring you, that might be something that you're not going to want to include in your breeding program. Do you want bees like this or bees like that? Spring buildup, colony population, mites and disease resistance. A lot of us queen bee breeders are selecting for Varroa tolerant stock, and how you do that, we'll get into that in greater detail. Do you just look at the mite drops? Do you look at hygienic behavior after doing a liquid nitrogen freezing of brood? Or do you look at mite washes, or do you look at the Varroa specific hygiene behavior itself? Again, I'll get into more detail about how do you determine that later in this presentation. There's honey production, how many pounds harvested. Something that we don't select for anymore, but which was important back in the day when comb honey was being produced. What do the combs look like? If we're producing comb honey, dry cappings are more attractive than wet cappings. The quality of the honey underneath is no different, but if you're having that on the shelf, a consumer might want to have comb honey that has a dry capping. And most of us are producing liquid honey, and comb honey is more of a niche product, but that's also something to pay attention to if that's something that you're interested in. For those of us up north, overwintering ability, that's one of the most easy things to breed for, because if the hive died, well, you're obviously not going to breed from that line of bees. But also frugality, something that isn't bred or selected for as much. You could have bees that survive winter, but you have to feed the heck out of them every year. That'll be less optimal than hives that go into winter with what they produced and really don't eat very much, and spring comes around and they still have plenty of honey left over. Oh, those are what we call frugal honeybees, and that might be a trait that you might be interested in having. Now, all bees will swarm, of course, but some strains might be a little bit more swarmy than others. All strains will swarm, obviously, if the right time of year comes and the brood nest is getting full and there's an older queen, but that's something that some beekeepers select for. Pollen gathering ability hasn't not been selected for as much, but I know back in the 50s they developed strains of bees that were better adapted to harvesting alfalfa pollen and then pollinating alfalfa. We've kind of gotten away with that with using other strains of bees for pollinating alfalfa. But that's something that could also be selected for, especially if you're in an area with a long winter. Maybe you want the bees to store a lot of honey or a lot of pollen for them to be able to use for raising brood later in the winter and early spring. And then I know some queen breeders select for queen longevity because that's an overall trait that will basically combine, if a hive lives a long time, the queen lives a long time, she hasn't been replaced, she's healthy, she's not diseased, that probably is an overall marker of queen viability and queen quality. And some other traits, responsiveness to stimulative feeding or maintaining large hive population year-round. That's not something that I select for. I don't send my bees to California for pollination, but if you were a commercial beekeeper, you might want to have a large hive population because those bees are not going to have to winter up north. You're going to take them down where it's warmer and you're going to be able to feed them, and you want to have a large hive population. If you have a small hive population, you might not be able to use that colony for pollination. And then, of course, if you're producing package bees, you might want to have lots of bees available to sell, and so these might be traits that you select for. Propolis used to be selected against back in the day because mainly it was inconvenient to the beekeepers. Nowadays, we're paying attention to it more because it might be helpful for overall colony health. Myself, I don't select for or against propolis, but I do track it. If someday, say it's definitively proven that propolis provides resistance against, I don't know what, nosema or something else, then I would be able to go through my spreadsheets and know which colonies tend to be more propolis producing, and if I wanted to, I could begin selecting for that very easily because I already have the data collected. Some beekeepers select for color, maybe dark bees or maybe light bees. I really like dark bees, and I have many of them, but personally, a good bee comes in any color. That's purely cosmetic, so I'm not going to pinch a queen or take her out of my breeding program because she's the wrong color. But that's something that some beekeepers do select for as well. One very important aspect of a honeybee breeding program is keeping good records. They could be as simple as you want or more detailed like some of these notes. That way you can gather data, gather information, compare the colony, how it performs over time, and also eventually how it performs against other colonies. It's always important to gather some data, even basic data such as how much honey is produced, if it's an older queen, if she needs to, when she was requeened, and so on. So let's go through some of the common characteristics that many beekeepers track. Honey production is an obvious one. How much honey was harvested over a season. Others weigh the entire colony and then measure it as it changes during the honey flow. And then you might consider, was this colony fed syrup? If you had to feed a lot of syrup and made a lot of bees and then they produced a lot of honey, that's one thing. But what if you didn't have to feed syrup and then they produced a lot of honey also? You're going to prefer the colony that you did not have to feed as much, that produced a similar or reasonable amount of honey. Are there differences between hives depending on location? Maybe one location is better than another and you might want to move your bees there. And are there differences between hives depending on the year? Obviously some years are drought years and they won't produce as much, and other years, you might have a great honey flow and they might be better. How do you compare them? I'll talk more about that in a little later in this presentation. Winter survival is a big one for those of us up north. Obviously, if the colony died, you can't breed from them. So what I do is I breed only from colonies that have survived at least 2 or more winters, because I know if they can do that, they are definitely adapted to our climate. But there's other characteristics that might be important too. I kind of mentioned frugality. It's something that we don't talk about a lot, but if you have to feed your bees, large amounts of syrup in order to get them to survive the winter, yeah, that's cheaper than buying new bees every spring. But on the other hand, wouldn't it be nice to have bees that don't eat that much honey over the winter, so you don't have to feed them as much? Or if they had a good honey year, maybe you don't have to feed them at all, and come spring they have plenty of honey left over. Then spring buildup might be something else that you might want to pay attention to. Uh, if you have long winters, there might not be much time, during the warm weather, and so spring buildup very fast is important. Of course, those colonies might be more likely to swarm if you're not paying attention. But if you have colonies that overwinter well, but they don't build up very quickly, they might never really reach much of a population high enough to collect honey during the honey flow. So that might be something you might pay attention to. Then, of course, there's temperament. These points or numbers that some folks use as an example, like in a spreadsheet. If you can go out there on a summer day with minimal smoke, don't have to put any protection on. Those are great bees. Those are the kinds you might want. Of course, you have other colonies that, they come after you. They follow you back to your vehicle. Maybe they follow you a few hundred yards. Those are ones you definitely don't want. But then there's also, colonies that are in between that, where maybe they're a little irritable, or maybe they're more irritable if there's maybe a cloudy day as compared to other hives. So there is some spectrum of temperament, and then calmness too. So not just if the bees attack you, but how do they act on the comb? I like bees where I can take the brood comb off and set it next to the hive, and they just stick on there. They don't really run around, and they don't fall off, and those are a lot better than bees that maybe are nervously running around or falling off in clusters off of the frame even as you're holding it. Swarm behavior, well, that's perfectly normal, and all types of honeybees will swarm, but some are more swarmy than others, and some strains, some ecotypes or races of honeybees are more swarm tendency than others. But you can still pay attention. This could be something that you might want to select for against either, at least to minimize it. Again, even if you select for that, you're never going to eliminate it. I mean, all honeybees will swarm given the right conditions. Selection for mite tolerance. This is a big one. Ever since Varroa came to North America, we've been selecting for tolerance of mites. The holy grail is to have honeybees that are completely mite resistant, and we're not there yet, unfortunately, but we do have strains of bees that are more tolerant, that they don't build up mite populations quite as fast. If they're in an isolated place and there's not a lot of mites coming in, and maybe you've treated them, the mite population doesn't build up as fast. Maybe they don't require mite treatments quite as often as other strains that don't have the mite resistance or tolerance. So how do you select for mite tolerance? There's different ways. I'm not going to read through all of this, obviously, but there's looking at the mite drop, doing mite washes, freeze-killed brood, grooming behavior, Varroa-specific hygiene. I'll kind of go through some of these. Mite drop is easy. You don't require any special skill. The problem is it's really not very reliable for determining what the population of mite is in the colony. And don't get me wrong, after I do a mite treatment, I love seeing all the dead mites on the bottom board. I love seeing all of them dead, and I also like it when I do a mite treatment and there's hardly any that fall off because there weren't very many mites in that colony. But it really doesn't tell you like a percentage of the mites in the colony. So it tells you that mites are there, and after a treatment, sure, you know that this colony had a lot of mites, and maybe that's not the one that you would breed from as compared to one that had the same mite treatment, same population of bees, and didn't have as many. But it's just not as specific or sensitive enough as compared to other techniques. Mite washes are considered the gold standard, usually with alcohol, though some folks use other things such as powdered sugar, to assess the population or percentage of mites within the colony. It's reasonably reliable. There are some caveats, of course, but you got to perform it correctly, and it only measures the phoretic mites, and I need to correct this. The mites are not really phoretic. They actually are feeding on the bees. As Dr. Sam Ramsey pointed out, phoretic is just traveling on the bees, but we really shouldn't be using the term phoretic. But anyway, it's basically measuring the mites that are on the bees rather than in the comb. So it does give you a reasonably reproducible measure of the mite population, and it can be used to compare to colonies within a yard. Freeze-killed brood is another technique that is used to look at brood removal. It helps measure hygienic behavior, not necessarily that specific to Varroa resistance, but it does measure hygienic behavior. It basically tells us how fast, how aggressively the bees will clean out the dead brood, the brood that was killed with liquid nitrogen. So it's good for chalk brood, European foul brood, maybe some other things. But it's not very strongly correlated to reduced mite population, and it does require liquid nitrogen, which is, potentially harmful, dangerous if you don't handle it correctly. Basically, liquid nitrogen is poured into a tube or a coffee can or PVC pipe that is pressed into the capped brood, and then looking 24 hours later, 48 hours later, how much of that brood has been removed, and the hives that remove more brood are more hygienic, and that might be something you decide you want to keep or select for in your breeding program. Grooming behavior. So it's an estimate of the damaged mites on the bottom of the board via microscopy, and looking for bite marks or dents on the bees themselves, or possibly where the legs had been bitten or chewed off. It helps assess how well the bees groom each other, called allo-grooming. Some people call this mite biting. It was popularized by Purdue University's breeding program. It is very tedious. You got to look at many, many mites with a microscope. It's not that specific. Not some of the damaged mites just were damaged as they fell through the colony, so it does not always predict mite tolerance either. And the bees will naturally groom the mites off of themselves. Here's a little video of a mite on the on the back of a bee. Most of them that are on the bee are actually on the underside and hard for the other bees to get to. And here's another bee trying to get to the mite. And as I was videoing this and watching this, I was silent, quietly saying, get that mite. It's right there. Can't you see it? And they do it by feel, with their mandibles. But often they're not very successful. But even if they're not successful, the mites will sometimes drop off. And if you watch closely, this mite's going to run onto the other bee. And she basically came off the original bee that she was on and onto the bee that was trying to do the grooming. So sometimes they get them and sometimes not. But this behavior is one that you could also select for. But again, the problem is most of the mites that are found on the bee are very tightly latched on, and it's hard for the bees to get to the mite on the underside. So this type of behavior might not be, at least not by itself, might not be the answer to mite tolerance. But as part of a whole group of behaviors the bees are using to fight off the mites, it might still be something helpful for overall mite tolerance. And then there's something that we call VSH, Varroa Specific Hygiene. Previously, this was called suppressed mite reproduction. The way that this is assessed is looking at the percent of reproducing mites versus non-reproducing mites in 100 cells of capped brood at around 7 to 11 days post-capping. This is when the pupa are purple, have purple eyes. This was developed by Harbo and is considered the gold standard to evaluate VSH trait. It's strongly correlated with the low rate of mite population increase, but it also is very tedious. It requires some microscope skills. And if the mite counts are already pretty low, it's hard to really get a good amount, to compare, one colony that has VSH versus colonies that don't. And like I said, it was previously called suppressed mite reproduction. So what happens with this behavior, the workers detect the mite, they uncap the cell, and they remove the pupa. Even if the mother mite survives, her offspring do not. In other cells, the mother mite might enter the cell, but for reasons we don't understand, she just doesn't reproduce. So even if the mother mite is not killed, the fact that she's not as successful at reproducing can be helpful to allow the bees to control the mite population, maybe through other behaviors like, the allo grooming and some of the things that are not successful by themselves, but maybe combined with this can help them keep the mite population under control. So using the technique as per Harbo to assess this, using forceps, you remove the cappings of cells of worker brood and look at the pupae, and they should be purple-eyed, which means they're between 7 and 11 days old. Under a dissecting microscope, you look at about 100 of these cells to determine how many mites are present, and then out of those, how many are non-reproducing mites versus reproducing mites. Then you determine the percentage of non-producing out of the total number of mites that were found. As you can imagine, this can be very time-consuming and tedious. A non-reproducing mite is one where only the mother mite is seen, but there's no eggs, no nymphs, or anything. She's just there hanging out, but for whatever reason, she's not reproducing. And then, of course, a reproducing mite is this. You see a lot of babies and eggs, and so you basically compare the non-reproducing mites to the reproducing mites and can determine overall, what is the percentage of mites that you have. And here's a video that I got off the internet just showing you what it looks like when you find a purple-eyed pupa and you pull it out, and there's the mother mite hanging off on the side, and oops, it looks like we got a whole family in there of baby mites. And so this is what we would consider to be a reproducing mother mite. So this one, yeah, this would be counted as a reproducing mother mite. There you go, a whole bunch of babies and in this cell. You score this behavior if the percent of non-reproducing mites compared to reproducing mites is the following, then the rate of VSH expression is this. So if less than the total amount of mites that are seen are non-reproducing, you have minimal VSH expression. If it's 33%, then it's 50% VSH. If half of the mites that are present are non-reproducing, then it's 75 VSH expression. And then if it's 100% of them non-reproducing, so there's not any of them reproducing at all, then that would be considered 100% VSH behavior. If you find no mites at all, that can happen if you have strong expression of VSH behavior. You should keep looking at more cells. If there's 0 mites of any kind, you don't know for sure if it's full expression, so you give a tentative score of 75% VSH. If you find 1 or 2 reproducing mites out of 150, but the population is too low to really know, then you just give them a tentative score of 50% VSH. And again, this is all as per Harbo. And if you want to know this in more detail, I certainly strongly recommend that you look up his publications. They're open access, and there's a lot of great information so that you can learn how to do this. It is a tedious method, and it would be nice if we could have other methods of assessing VSH hygiene without having to look at so many worker brood and having to do all of this, calculations and whatnot. But at least right now, as at the time of this presentation, this is the best we have for determining Varroa-specific hygiene. Okay, let's talk about breeding programs. When we breed other types of livestock, whether it's cattle or dogs, or other animals, there's different types of breeding programs that are used by breeders. There are what we call line bred, which is common with many Italian strains, Carniolan strains. Hybrid, really no longer available. When I first started out back in the day, they had the Starline and the Midnight bees, but they're not available. There's cross-bred bees, one with an Italian and a Russian, or Italian and Carniolan. Closed population breeding, a perfect example of that is Dr. Kobe's New World Carniolans. Instrumentally inseminated, these are breeder queens. Most of you are not going to be doing this. It is very, it is a very specialized skill. It is very helpful. I use it for my own breeding stock, but it's so specialized I'm not currently even using that to sell these queens. These are more to just keep the genetics really dialed in for whatever strain that I'm trying to breed. And then unfortunately what happens with many breeding is just random open mating. The queen flies around and mates with whatever. There's nothing wrong with these queens if you're not in a place where there's genetics you don't want. You're not in an Africanized honeybee area. Then this is fine. These bees are going to be better than many of that you will buy that were commercially produced, because they were produced locally and the queens weren't stressed when they were mailed. But you just don't know what the genetics were. Some people call these mongrel bees or mutt bees or whatever, which is a little insulting. I mean, this is what bees do out in nature, and some of these bees of unknown genetics can be very good stock. You just won't be able to breed for some of the characteristics as much as you would like. So basically, with the random open mating, the queens mate with whatever drones happen to be flying around. It's easy, you don't have to really do any planning at all. But if there's lots of unrelated drones in the vicinity, these can result in good production queens. But you just don't know what the offspring are going to be like, and so that there's a risk of unwanted genetics. Or if you're in a very isolated location, like a mountain valley or something, and you're only breeding with your own bees, and you don't have enough genetic diversity, then you could have inbreeding problems. That's pretty unlikely unless you're in a place that's very isolated, however. Line bred or line breeding. There are many Italian strains and other strains. They have different lines within the same population, and it is more predictable as compared to completely unselected bees. Sometimes outside lines are brought in to lower the risk of inbreeding, but there's still some greater unpredictability as compared to closed population breeding or hybrid breeding. Hybrid breeding, this is common in certain things like vegetables. You want to get some corn, you can get hybrid corn. Sometimes other chickens, there's different types of hybrid chickens or crossbred chickens. The classic examples are the Starline and the Midnight hybrids that were available in the 70s and 80s. These were great bees. I had them when I was first starting out as a kid. They have two or more controlled lines, often inbred lines. They're very predictable, and the results, they have what we call hybrid vigor. The problem is you have to maintain these inbred lines over the long term, which can be very difficult. It's difficult to maintain these lines in a way that the queens would be affordable to anybody that you might sell from. And so that's unfortunately why the hybrid bees went away over time. It just wasn't anything that was commercially viable. Crossbred bees. So this would be, and these are frequently, easily available commercially, like an Italian Carniolan or Italian Russian or whatnot. And because these are unrelated ecotypes or races of bees, they often will have greater vigor than the underlying foundation stock, but not quite as predictable as a hybrid. Sometimes you can get unwanted characteristics. Sometimes these bees can be very vigorous, including in how defensive they are, and they're very vigorous at defending the hive and coming at you. And that's sometimes how I've seen the quote-unquote Russian bees that were more defensive. Many of them were actually Russian crossbreeds, and that's why they were more defensive than if you would have a pure Russian. And so that might be, part of the explanation why some bees, have a reputation for more defensive, but it's not really, if you had the more pure underlying strain, it might really not be so big of a deal. Indeed, we actually see this as the Africanized bees are coming up and crossing with the European bees, often the crossbreed, at least until they get more fully Africanized, are actually much more defensive for a time, as compared to when, they're fully Africanized, which are still very defensive enough on their own. Closed population breeding. So the classic example is Dr. Sue Kobe's New World Carniolans, which she created by having a closed population of stock that was selected over time. And by doing this, by having a closed population, you're not going to have as many random unexpected characteristics compared to just random open mating or non-selected lines. The greatest risk with this, of course, is inbreeding, because lack of genetic diversity can result in that and decreased vigor, or you might have unwanted recessive traits showing up too. So you have to be very careful to avoid that. Instrumental insemination, we use that for breeder queens. Semen is collected from selected drones, and then that semen is inseminated into virgin queens using microscopy and a special insemination apparatus. You have complete control over breeding and genetics. You know exactly what genetics are going into your queens. But it is expensive, and there's certainly a learning curve. If you're not careful, you can damage the queens. Inseminated queens had a reputation for not, having the quality or not lasting as long. If you use good technique with your inseminated queens and you care for them, they can be just as high quality as an open mated queen, but there is a learning curve and there's a lot of skill involved. So this breeding is, type of breeding is really not for most queen bee breeders. Well, that brings us to which breeding program is best. Well, it really depends, but unless you mate your queens in an isolated location or use instrumental insemination, true controlled breeding is difficult to achieve. But you can kind of stack the cards by having drone holding colonies surrounding your mating yard, as I mentioned in a previous presentation. If you are going to try closed population breeding, you need at least 35 to 50 breeding colonies to avoid inbreeding. And if you're only going to breed from the top 10 or 20% of your colonies instead of all of them, you probably need more like 170, 250 colonies. If you're going to have a completely isolated breeding population, like on an island or in a mountain valley, most places there's going to be feral bees around and other beekeepers. So having inbreeding problems are not really, as big of a problem as they might be. But you really want to avoid inbreeding as much as possible. So that's my one comment on that. So for small queen breeders, who might not have like an island to put their bees on or a mountain valley, you can still control your breeding stock in different ways. One way is, select the stock from the top 10 or 20% of your colonies, looking at multiple characteristics. If colonies have any unwanted characteristics, remove them immediately, especially things like excessive defensiveness. That's one that you definitely don't want. If a bee or if a colony has a very high amount of mites as compared to other colonies, that's probably that should be taken out of your breeding program right away too. Be careful to not graft from the same related lines of queens year after year. It's very tempting to do that. You might have some rock star queens and their daughters are also rock stars, and you just have there's a tendency to want to just graft from them, but eventually, you could get some inbreeding problems. Try to flood the local drone congregation areas with drones from your selected drone mother colonies, which are unrelated to the queen mothers. Occasionally bring in some unrelated breeder queens that have desirable characteristics, VSH trait and whatnot. Try to select between 2 to 5 traits using a selection index. And what is a selection index? We will cover selection index breeding next. So the problem with trying to breed for multiple characteristics at the same time, if you're trying to produce the perfect colony, if you're trying to select for, one perfect colony, one characteristics, the chances of finding that perfect colony, is pretty low. You need to have 500 colonies in every generation. If you're trying to select for 6 characteristics, you need like 1.5 million colonies. And so that's kind of an impossible expectation. So what we use instead is something called selection index. This is something commonly used with livestock breeding. Whenever I mention this selection index to a group of beekeepers, if any of them have any background in livestock breeding, whether breeding cattle or anything, they understand what selection index is. They understand that fairly well. But in beekeeping, a lot of beekeepers are unfamiliar with it. It's not a term that's commonly used or a method that's commonly used in breeding, unfortunately. Some traits are more inheritable than others. We talk about this called heritability. Some traits are more inheritable. For example, defensiveness. That can be a bad thing. If you've got nice and gentle bees and then your neighbor brings in some bees from who knows where and they're really aggressive and defensive and they're sending up drones to mate with your virgin queens, now suddenly your bees are also very defensive. And, that might not make you very happy with your neighboring beekeeper. But and that can happen fairly quickly. But on the flip side of that, if you select for bees that are not defensive and you can control the genetics, you can breed that out fairly quickly as well within 2 or 3 generations. Other types of traits are a little bit harder to breed for. Honey production is one, because there's so many genetics that it's not just how much the bees hoard honey, but how much population do they produce? What type of honey flow you're having. There's so many factors that affect honey production besides only the genetic factor and how good the bees are at hoarding nectar and making honey. The way to really look at heritability of traits, the genes themselves are only one thing. We call that the genotype. Environmental factors. Like I mentioned, if you're selecting for honey production, it's going to depend on where you put that hive, what type of year you're having. All of those other factors are going to affect the expression of that genotype. And then other non-related genes. If you have a very productive, if you have bees with a genotype that should make them very productive to produce lots of honey, but other genes are not allowing them to build up a big population and they have a small little hive, that little hive of bees that could be very productive is not going to be very productive because there's just not enough bees to go out and protect to harvest the nectar and produce the honey. And it's the same way with any other trait they may have. We call the expression of the trait the phenotype. And so you need to keep that in mind, that there's many different factors that contribute to the trait as it is being expressed in a colony of bees. So one way to get around some of these things, one way to get around variability like year to year, because of the location, is to use selection index breeding. And like I said, this type of breeding program has been used in other species of livestock for many decades. It has not been used as much in honeybee breeding. Basically, you collect data, whatever that is. It could be how many pounds of honey is harvested, or it could be, what is the percentage of mites, on a mite wash done at the same time in all of your colonies. It could be just a scoring, is this colony, a high number in defensiveness or a low number? And then it's converted to what we call z-scores. What is a z-score? Well, it's something that we use as statistical analysis of an individual, in our case, an individual colony, and thereby the queen. It's representing the individual's position within a given population. And there's a formula. Personally, I don't like math. I mean, this math is really easy, but I don't like math, so I put this into a spreadsheet so it's calculated for me. But basically, the z-score is the individual's colony score compared to the average score for that bee yard, with the standard deviation of that scores within that apiary. So I'll get to that for what this means. So this right here is what we call a bell curve. Those of you that know even a little bit of statistics understand a bell curve, and it basically represents the number of individuals spread out over a certain measure. And there's what we call the mean, and that's where most of the numbers of individuals lie. they could have a negative or a positive z-score. So if a colony is a lower producing, I'm just sticking with honey production because it's easy to understand, but if you have a colony that is low in honey production, that's going to have, as compared to the mean, as compared to the population, that's going to have a negative z-score. And if you have a colony that is a high producing honey producing colony, that's going to have a positive z-score. So that's where you would want that colony to have a positive z-score. And the idea is, with a breeding program, you want to move the population over so that as you breed, the whole population, the bell curve moves over. So you have more bees tending towards the positive. Now, there might be times when you want the negative z-score is what you're selecting for. Where would that be? Where you want to move the population over to a lower z-score. That would be mites, or a mite population is a perfect example. So you want to breed for ones that have a lower, that are less than average. So you want to have colonies that have a lower number on the mite wash, or that have a lower population of mites. That's where a negative z-score would be a positive thing to select for. This is just an oversimplified little spreadsheet that just to show you what I'm talking about. There's 5 colonies, and obviously in a breeding program you'd have many more than this. And this is a breeding program that's selecting for honey production, temperament, mite count, hygienic behavior. So honey production, obviously more is better. There's temperament and there's mite count. Obviously with mite count, lower is better. Hygienic behavior, maybe it's it would be selected, with nitrogen killed brood. You got this rock star down here. Look at this, colony number 4, 180 pounds of honey. I mean, compared to all the others, it's like, more than 2 times as much as the next best colony, and even 6 times as much as the worst producing colony. But unfortunately, even though this colony was a real rock star with honey production, they were pretty bad when it came to the mite count. They had a really high mite count on the mite wash. So that's not so good. If you didn't care about mites and you weren't going to breed for that, then you wouldn't matter. But if you're trying to breed for mite tolerance, sure, you want the honey production, but maybe this mite count is going to be something that's going to be a negative towards that colony. Now you got this colony up here. They had a great temperament. They had a very low mite count. So that looks nice. This is a nice gentle colony. They're keeping the mite population down. But look at the honey production. That's so low. I mean, I guess if you wanted to have a colony of bees as for pets, to have in your backyard, and you really weren't going to harvest honey from them, maybe this is what you'd be okay with that. They were really gentle to work, and they had low mites, so they survived, hopefully. But they just didn't make you much honey. Myself, I prefer to have my bees produce some honey, in a good year. I mean, they need to kind of earn their keep. So I do like to have them to produce honey for us. This is where z-scores come in, and so that spreadsheet basically calculated the z-score comparing each of these colonies compared to where they were. Just looking at colony number 4, it obviously was very high in the z-score for honey production, but it also had a very low z-score, negative, because for the mite count. And these can all be added up to give a total score for that colony. And the z-scores that are less, wanted are made to be a negative score, so it detracts from the overall score. And so you look at it, colony number 4, a great honey producer, but look, it had the lowest score of all, mainly because the mite count was so bad. The highest scoring colonies were number 3 and number 5. That might be a surprise to you. They weren't the rock stars when it came to honey production. They did good honey production, but again, you're not just selecting only for honey. You're looking at temperament. They both had good temperament. They both had low mite counts, and they had pretty darn good hygienic behavior. So those are the colonies that in this breeding program, they had the best scores. Now, maybe you do value honey production, say, twice as much as hygienic behavior. So you could multiply those scores under the z-scores to weight it more heavily towards honey production. So there's ways you can play around with this. And this presentation is, I can't really go into the detail of selection index breeding as much as I would like to, because I could literally spend an hour talking about it, and I would bore all of you to tears, and you would fall asleep and skip ahead or whatnot. But there are, you can Google it. There are where they did talk about selection index in queen bee breeding. So if you really want to learn how to do this better, I recommend you try to pull up some of these studies of selection index breeding, and they can really help you learn how to do this if this is something that you're serious about and want to add it into your breeding program. Well, that brings us to the end of this presentation, Designing Your Breeding Program. To summarize that, once you've learned how to rear queens and produce queens, the next step is to start selecting for them so that you can have a breeding program to select for the traits that you want. And, it's going to really depend on what you want. What you want might be very different than what I want. So try to think of about 2 to 5 traits that you'd like to breed for. Keep good records. That's really important because if you're not keeping track of information or data, you really don't know anything. Try to choose your breeding stock from the top 10 or 20% and using a selection index. Remove colonies with unwanted characteristics from your population. Excessive defensiveness, hives that are just mite bombs full of mites, whatever is a characteristic that you don't want, make sure that even if they're good in everything else, if they're really bad in other things, then probably you want to not include them in your breeding population. I have to admit, sometimes that's really hard. I have hives that, when I eyeball them, they look really good, but when I dial in, look at all the other information, they're not really quite as good as I thought they would have been. Try to avoid inbreeding by grafting from the same related lines of mother queens year after year. Try to flood the drone congregation areas with drones from your selected drone mother colonies, and then occasionally bring in some unrelated breeder queens which have genetics that you want, your VSH or some other trait. That helps you avoid inbreeding, but also helps you raise the expression of certain traits that you're trying to breed for. I don't know where I first heard this quote. It certainly wasn't me. I don't know if it was Dr. Sue Kobe or someone else, but basically, we're trying to improve our entire population of bees as we breed. So don't breed from the breed from the entire population. Don't breed from only a few outliers. Don't breed from the few freaks that show up. You might have some rock star colonies, and if they have all the characteristics that you want, then great. But if they're only good in 1 or 2, but they're not so good in others, then be aware of that and try to breed from the entire population. So that brings us to the end of this presentation. The next and final presentation of this series, I will talk about some of the methods on selecting and trying to breed the highest quality queens possible. Thank you for watching these presentations. I truly hope that they're useful in helping you breed the highest quality, best queens possible. Thank you again so much.